I've been getting steadily more sick every day since Friday.
Is September 6th this coming year?
What?
September 6th.
That's a thing?
It happens every time in September. Somebody gets sick at some point.
I got home at 1 a.m. last night for my friend's wedding.
Okay, well, that's probably why.
Where'd your friend get married?
In Saratoga. It was beautiful. Very godly couple.
Wait, how old is he?
He's my year. And his fiance or his wife now is 2 years younger than him, so pretty young.
You said Beyonce?
Yeah.
Oh, Beyonce.
But I support that. You know, it's beautiful. All right, can you guys please be quiet? Thank you.
Hey, people get married at like 19.
Christians also usually get married younger.
To Germany, at like literally tomorrow, I can do free food. And then Oktoberfest starts.
Guys, be quiet. Let's start.
I'm not going there.
I don't want to do that. This is better. Well, whoever is listening to the YouTube recording will have their ears shattered now. Okay, the unit circle helps us to define sine and cosine for angles that are not acute, right? So far we've only gone over how to find sine and cosine if the angle is between 0 and 90, right? Because that allows us to draw a triangle. But what if we wanted to find sine and cosine of angles greater than 90 degrees? We would have to use the unit circle. The unit circle is basically just a circle centered at the origin with radius 1. You guys have all learned this, I think, in algebra. It's a circle centered at the origin with radius 1, and based on the unit circle, a point that is located at a certain angle theta has coordinates. If this radius is 1, this point will have coordinates cosine theta, comma sine theta. And so the unit circle is very important because it helps us to define cosine and cosine and sine for angles that might be like here, where like theta is greater than 90 degrees, right? This would be, I don't know, theta equals 4 pi over 3 or something, right? In this case, we wouldn't be able to find cosine and sine based on a right triangle. We would have to use the unit circle. And the coordinates of this point are defined as cosine theta and sine theta. So the cosine is always the x value, and the sine is always the y value. Okay, I'll write that. Don't mix them up, okay? Cosine is the x value, and the sine is the y value. If you mix these two up, you're going to get every single question on every test wrong. So that's pretty dangerous, isn't that? Okay, a good way to remember it, one that I came up with several hours ago. You know, cosine, it starts with a C, which comes before the S in sine alphabetically. So you know it has to be the first one in the coordinate. Yeah. Yeah, I came up with that in my 1A. Anybody else have a better way of remembering it?
No, that's perfect.
Yeah, I know, right? Yeah. Cosine, you know, C comes before S, so it's the x value, not the y value. Okay, so we can do a quick example of how we might find real trig or sine and cosine functions in practice using this unit circle. So I'm going to draw a big unit circle, and we're going to use the unit circle to find what?
You could put them together and make cousin, but have it be 2s.
Cosine?
I mean, you say a little bit. But
Okay,
it works out.
that's not horrible.
I think I like
The what?
the cousin one.
Cousin? Okay, it's good. Whatever, you know, gets you to remember it correctly. You know,
Things like
we'll see based on your test scores which one worked better, which way of remembering it. Whoever gets a 0 on the test will know it doesn't work. Okay, let's say we have a question and it asks us to find, what's sine of pi over 4? Sine pi over 4. Okay, pi over 4, how many degrees? 45. Looks like we all memorized that. So that's going to correspond to this point. So in order to find sine pi over 4, I would want to know what is the y-coordinate of this point on the unit circle. Okay, and so this is going to be a right triangle if I drop a perpendicular down to the x-axis. And the hypotenuse, or the radius, is 1, right? Because it's a unit circle. And I know this is a 45-degree angle. And so all I need to do is to find the coordinates of this point is to find this width, right, which is just root 2 over 2, because it's a 45, 45, 90 triangle, and also this height, which is also root 2 over 2. So that means I know that the coordinates of this point are root 2 over 2, comma, root 2 over 2, which means that sine pi over 4 is my y-coordinate, right, because s comes after c. And so sine pi over 4 is root 2 over 2. Okay, that's pretty straightforward. We didn't even really need to use the unit circle, but just a quick example. Questions?
Wait, where did you get root 2 over 2 from? Oh, yeah.
Root 2 over 2 is also 1 over root 2, right?
Yeah.
So I divided the hypotenuse by root 2. Okay? Let's do a more interesting one. Let's say we were asked what is cosine of 2 pi over 3. Okay? 2 pi over 3 is 120 degrees, right? So this would be impossible using our right triangle. We can't draw a right triangle with a 120-degree angle. So we need to use our unit circle. Now, 120 degrees, as we know, is going to be around here, right? It's 180 minus 60 degrees, right? Right, 2 pi over 3 is equal to pi minus pi over 3. Okay, in general, the best way to locate things on the unit circle is to figure out, what's an angle that I know it's close to, and then how can I get to there from that angle. So for example, 2 pi over 3, I know it's close to pi, which is here, right? That's 180 degrees. So I have to go down to pi and then go pi over 3 backwards, or 60 degrees backwards, and that's going to get me to my point. So that's a quick way of figuring out where those are. Okay, so that's going to be this angle, and this is 2 pi over 3, 120 degrees. All I'm going to do is drop a perpendicular down to the x-axis, and so now I have a right triangle, and this angle is pi over 3, right? 60 degrees. And so if this length is 1, then this length is a half, and this length is root 3 over 2. Okay, because it's a 30, 60, 90 triangle. Therefore, the coordinates of this point are going to be negative 1/2, right? Because it's on the negative side of the x-axis, and this length is 1/2. So it's going to be negative 1/2, comma, root 3 over 2. And so cosine 2 pi over 3 is just going to be the x-coordinate of that point, which is negative 1/2. So this would be something that would be impossible to find with a right triangle, but defining our trig functions using a unit circle makes it possible. Yep. Some what? Yep. Okay, got it? All right. We'll do another example. This also allows us to find sine and cosine for like a right angle. Okay, so let's say we were asked to find sine pi over 2, which is 90 degrees, cosine pi over 2, and also tangent pi over 2. Now this would be impossible with a right triangle because that's a 90-degree angle, right? We can't do that with a right triangle. So once again, we're going to draw our unit circle. Okay? And pi over 2 is simply located right here, right? It's, we're going this direction, pi over 2. So we're interested in the coordinates of this point. That's super easy to find, right? 0, comma 1. And so that tells us that sine pi over 2, the y value, right, as comes after c, and so sine pi over 2 is 1, cosine pi over 2 is 0, right, the x-coordinate, and that actually means tangent pi over 2, right, which is sine pi over 2 over cosine pi over 2, based on the identity we learned last class, is undefined. It's 1 over 0. So actually, tangent and cotangent, and also secant and cosecant will frequently be undefined when this happens. Okay? That's how we use the unit circle to do these things. Any questions? All right, I'll let you guys do an example. You can do it with your buddy. Please find sine (4 pi over 3) and cosine 4 pi over 3 and tangent 4 pi over 3. Okay. So first think about where it is on the unit circle, 4 pi over 3. How do we get to 4 pi over 3? That's like pi plus pi over 3. So it should be 60 degrees more than pi, or 180. So that's a good way to think about it. And then draw a right triangle. And then just find the coordinates. Anybody got it? The radius or hypotenuse is 1.
Sine is negative 1/2. Cosine is negative
Wrong.
2.
Wrong.
Oh,
Wrong. Yep.
Sine is negative root 3 over 2, and cosine is 1/2. Negative 1/2.
Very good. Tangent? Tangent?
Tangent is, wait, root 3. Negative, positive root 3.
Yes, very good. Okay, good job. That can earn a haichu. Let me find them. Alexandra, have you ever received a haichu?
No, I haven't.
This is your first time. Has anybody else in here other than Eleanor not received a haichu before? Well, step it up. Raspberries, very good. Okay, so we're going to follow our same process as before. We're going to drop a perpendicular down to the x-axis. Well, now it's up to the x-axis. Okay, and this angle is 60 degrees, right? Because, or pi over 3, because we're going, right, 4 pi over 3 is just pi plus pi over 3, so it's pi over 3 past the negative x-axis. And so that means that if this hypotenuse or radius is 1, then this length, it's an ugly brace, this length is 1/2, and this length is root 3 over 2. Okay, 30, 60, 90 triangle. And so that means the coordinates of this point are -1/2, comma, -√3/2. Right, they're both going to be negative because we're in quadrant 3. And so we're able to write sine of 4 pi over 3 is equal to -√3/2 because it's the y value, right? S comes after c. And then cosine is -1/2. Tangent 4 pi over 3 is just going to be sine over cosine, which is √3. Okay, any questions? I got it from finding this length, and I know that length because of the 30, 60, 90 triangle. Okay, so if this hypotenuse is length 1, if this hypotenuse is length 1, then that means that this length is half of the hypotenuse, and then this length is square root 3 times whatever I have here. That's the 30, 60, 90 triangle that I asked you guys all to memorize. Okay? Right, because this angle is 60 and this angle is 30. Pi over 3 and pi over 6. Any questions? All right, I'll show you guys how I usually do this quickly in my head instead of having to draw a triangle every time. You know, by the time the test rolls around, you should be able to do these 3 trig functions in maybe 5 seconds in your head. Okay, so everything we just did, you need to be able to visualize in your head without writing anything down and be able to do it in about 5 seconds. Okay, so do a lot of practice. And I'll show you some tricks that I usually use to do it in my head quickly. Well, I'm not that fast at it, so, but maybe a little faster than you guys, so I'll help you guys out. So let's say I have something like find sine of 11 pi over 6. Well, let's start with something easier. Let's start with the multiple of pi over 4, okay? So 7 pi over 4, okay? So as a general rule, when you have a multiple of pi over 4, like pi over 4, 3 pi over 4, 5 pi over 4, those are always going to be, you know, square root 2, comma square root of 2, right? The coordinates are always going to be something like that because you know that you're going to have a 45, 45, 90 triangle, right? Because it's a multiple of pi over 4, which is 45 degrees. And so, you know, no matter where it is on this unit circle, you're always going to get this triangle, 45, 45, 90 triangle somehow. And so you know it has to be some kind of root 2 over 2, okay? So first thing I'm going to do, and usually I would do this all in my head, and you guys will soon be able to do that too. I'm going to draw or visualize a unit circle, and I'm going to try to figure out where this angle is on the unit circle. And to do that, I locate something that I know, like pi or 2 pi, and I try to figure out where this is closest to, okay? Now 7 pi over 4, I can quickly find in my head that this is 2 pi minus pi over 4, right? And so I know it's going to be somewhere close to the 2 pi, right, 360 degrees, and then I'm going to go backwards pi over 4. So I know it's here. I know that this angle is 7 pi over 4, and that's something you should be able to visualize in your head. Okay? So when I think 7 pi over 4, I just think, oh, that's close to 2 pi, and then I should go pi over 4 backwards. Okay? And I know it has to be root 2 over 2 in both the x and y coordinates. I just don't know whether it's plus or minus, right? But, you know, now that I know where it is on the diagram, on the unit circle, let me just keep this here. I know that this is going to be positive in the x coordinate, right? Because it's on this, it's in this quadrant, and it's going to be negative in the y coordinate. So that's how I can quickly find that coordinate. And so I would be able to write sine 7 pi over 4 is equal to negative root 2 over 2. And cosine 7 pi over 4 is positive root 2 over 2. And tangent 7 pi over 4 would just be negative 1. I divided sine by cosine. Okay? So that's how you do this quickly for multiples of pi over 4. Okay, any questions about that? Yeah,
You said 5 seconds?
yeah,
Okay.
maybe 10 seconds. I think my speed is 5 seconds, so 10 seconds for you guys. Okay, then let me show you guys multiples of pi over 3 and pi over 6. Those are a little harder. Okay, so let's say I have, I don't know, 5 pi over 3. Okay. So 5 pi over 3, first I'm going to think in my head, what is this closest to? It's closest to 2 pi, because 2 pi is 6 pi over 3, right? So I know it's closest to 2 pi, and it's going to be 2 pi minus pi over 3. So I know I should go to 360 and then go backwards pi over 3. Okay? So it's going to be right here. What the frick? Right here. Normally, I wouldn't even visualize the line. I just locate the point on the circle, okay? Okay, so as a general rule, everything that's a multiple of pi over 3 or a multiple of pi over 6 will always look something like this. It'll always be plus or minus 1/2, comma, plus or minus root 3 over 2, or it'll be plus or minus root 3 over 2, comma, plus or minus 1/2. And the reason is because it's a multiple of pi over 3 or pi over 6, you know that the resulting triangle is going to be a 30, 60, 90 triangle. And so you're going to know it's going to be either 1/2 or it's going to be root 3 over 2 in those coordinates. You just don't know whether it's positive or negative, and you also don't know what order it's in. That's why we need the unit circle still. Okay? But I'm going to visualize where the point is on the unit circle. And then I'm going to think about which length is shorter and which one is longer. Okay? What I mean is that I'm going to think about the x-coordinate of this point, which is around here, and then I'm going to think about the y-coordinate, which is around here. And clearly the x-coordinate is the short one, right? The y-coordinate is the long one. And so I know that since 1/2 is smaller than root 3 over 2, I know that this length is going to be 1/2, and this length is going to be root 3 over 2. That's kind of my trick for finding it quickly. Okay? And if I draw the location of the point well, it's going to be super clear to me which one is shorter and which one is longer. Right? Because 1/2 is 0.5, right? And root 3 over 2 is 0.866. Yes. Okay, so I know that the root 3 over 2 is the long one. And so that helps me to really quickly locate the coordinates. I know that the x-coordinate is going to be positive 1/2, and the y-coordinate is going to be negative root 3 over 2. Okay? Easy, right? That's how you do it in your head. So in my head, I would look at 5 pi over 3, I would visualize its location on the unit circle, and then I would think about, is the x-coordinate the short one or the long one, and then deduce based on that. Okay? I'll show you another example. Let's do 11 pi over 6. No, that's too easy. Or too similar, that's what I meant. Let's do 7 pi over 6. Okay? So it's a multiple of pi over 3, and it's a multiple of pi over 6. So I know it's going to be something with 1/2 and root 3 over 2. I also know that this is close to pi, right? This is just pi plus pi over 6. So I know that what I'm going to have to do is I'm going to have to go to pi and then go pi over 6 more, just a little bit extra, 30 degrees extra. And so on my unit circle, I'm going to be right here. Right there. Okay? And based on the location on the unit circle, I know that my x-coordinate is the big one, is the long one, and my y-coordinate is the short one, right? Because this is so much closer to 1, and this is a smaller value. And so I know that it should be negative root 3 over 2, comma, negative 1/2. Because the negative root 3 over 2 is the, right? Root 3 over 2 is bigger than half. And so I can just guess, I guess, if that makes sense. So cosine 7 pi over 6 is equal to negative root 3 over 2, and sine is negative 1/2. And tangent would be root 3 over 3, which you can confirm on your own. Are there any questions?
Is there necessarily a fast way to calculate tan in this scenario? Or do you just have cosine over cosine?
Sine over cosine, you mean,
Sine
is
over
the most reliable way. You could do a quicker way.
But it's less rough.
Tangent is also always the slope of this line.
Oh, it is.
Yes. And so based on the slope of this line, I know it's shallow, so it should be less than 1. So therefore it should be root 3 over 3. If it was here, then it would be root 3. If it was here, it would be negative root 3. If it was here, it would be positive root 3 over 3. That's another trick. Maybe I'll show you guys next class. Well, I just came up with it, so. Normally I do sine over cosine. Yeah. Okay, any questions about that? Let me also show you guys something quite important, which is what if we have an angle that's greater than 2 pi? Okay, so to find sine and cosine for angles greater than 2 pi, we're going to utilize a very important fact, which is that sine and cosine have a period of 2 pi. You guys know what period means? It just means the interval over which a function begins to repeat itself. Okay, so if we just think about the unit circle, right? As our angle begins to increase over 2 pi, it simply increases, it simply repeats what it originally was, right? So for example, this angle here, which is like pi over 6, well, this angle is also 13 pi over 6, right? Why is that? It's also the equivalent of if we had gone around the circle the whole time and then did pi over 6. So 13 pi over 6 is just pi over 6 plus 2 pi, right? So if we have a annoying angle that's kind of too big for us to really visualize well, what we can do is simply subtract or add multiples of 2 pi, and sine and cosine are going to be the same. For instance, if you had like sine of 13 pi over 3, you know, nobody wants to figure this out on the unit circle, right? This angle is greater than 4 pi. How many degrees is it? It's like 780 degrees, right? That's too big. So what we're going to do is we're going to subtract multiples of 2 pi until we get something manageable. We're going to subtract 4 pi. Okay? And because the sine function has a period of 2 pi, this isn't going to affect the value of the sine function, but it's going to be the same. And so sine of 13 pi over 3 minus 4 pi is pi over 3. And that's something we know, right? Sine of pi over 3, I'm going to visualize it on my unit circle. Sine pi over 3, okay, root 3 over 2. Okay? You guys need to practice this a lot. Practice a lot, until you can do it in 10 seconds in your head.
Wait, why do we need to be able to do it in 10 seconds?
Because our future units are going to use so much trig that if you're drawing a unit circle for every single thing, you will take forever. Okay, let's talk about our last thing, which is the even and oddness of sine and cosine. Anybody want to guess which one is even and which one is odd?
Sine is on.
Very good. If you guys recall, an even function obeys this property. F of x equals f of negative x. And an odd function obeys this property. F of negative x equals negative f of x. Okay? And so we can really easily figure out, based on the unit circle, whether sine and cosine are even or odd. We're going to draw a unit circle. And let's just draw a representative angle, maybe right here. We'll call this theta. And this is going to have, let's say, coordinates x comma y. Okay? So which quadrant is theta in? You guys know? 2, yeah. Right. 1, 2, 3, 4. Goes counterclockwise. Now, negative theta, on the other hand, is right here, right? Negative theta is simply if we went the same number of degrees except in the clockwise direction. And the coordinates for this point, as you can see, the x-coordinate is unchanged, but the y-coordinate is flipped, right? And so this actually allows us to establish these relations. Cosine theta, right, this value here, cosine theta equals cosine of negative theta, right? Because this value here is cosine of negative theta, the x-coordinate of the negative theta angle. On the other hand, sine of theta, which is this coordinate here, is negative sine of negative theta, which is this coordinate here. So based on the unit circle, we can very easily see that cosine is even and sine is odd. This will be helpful for some homework problems. Questions? Mila?
Why isn't it negative x, negative y? Isn't it the point involving negative?
Oh, it's because this original x value is negative. Okay.
And this applies in all 4 quadrants, that sine is odd.
Yes. Ayla, what I mean is that in this coordinate here, x is a negative number and y is a positive number. So in this coordinate here, x is still a negative number, but negative y becomes is a negative number, right? Yeah. So that's why the signs are weird. Okay, questions? On the last question of the homework, it's also important to note that sine of pi minus theta is equal to sine theta, and sine of theta plus pi is equal to negative sine of theta. And you can very easily confirm this using a unit circle, which I will leave as an exercise for the reader. Any questions about the whole lecture?